Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. I am Dr. Sadabbas. In this lecture, we will discuss the concepts related to quality engineering process. In particular, we will discuss the activities involved in quality engineering process. We will also discuss the quality improvement paradigm and will discuss the relationship of this paradigm with the quality engineering approach. Moreover, we will have discussion on quality engineering aspects in the software process. Furthermore, we will discuss the quality engineering effort profile for different life cycle models. Before starting our discussion on software quality engineering, we need to understand the concept of software quality assurance so that we can distinguish between these two concepts and build our foundational concepts. So here we have two definitions of software quality assurance, and let's see the first definition. According to this definition, software quality assurance is a planned and systematic approach to the evaluation of the quality and adherence to the software product standards, processes, and procedures. So like here we have some keywords. For example, it is a planned set of activities, systematic set of activities. And what is the purpose of these activities? That they are meant to evaluate the quality. So we see the second definition. According to this definition, uh, it is to assure that the standards, processes, and procedures are appropriate for the project and are correctly implemented. So you see that here, uh, like we can see that SQ is in fact a way of monitoring the software engineering process uh, and uh, and it is in fact to ensure that the standards and procedures while developing the software they are being met or not. So different customers and different users they have different quality expectations under different market environments. Therefore, we need to move beyond just performing quality assurance activities towards quality engineering by managing these quality expectations as an engineering problem. So for that, we will have to define software quality engineering formally. Here we have a formal definition of software quality engineering. And according to this definition, software quality engineering is the application of a continuous, systematic, disciplined, and quantifiable approach to the development and maintenance of quality throughout the whole life cycle of software products and systems. So this definition emphasizes on in fact managing the quality throughout the life cycle as formally as possible. That is, we need to look this process as an engineering process so that we can apply the practical knowledge in a more effective and better way to manage and oversee the development activities throughout the life cycle of the software. So here we have, you can see we have some important keywords. For example, uh, continuous. That what do we mean by continuous? That it is in fact continuously applying some approaches or some activities. So what is the purpose of continuously applying? For example, if an approach is not able to achieve the desired effect for the first time, then we need to apply, we need to improve our existing approach and apply it again so that we can achieve our desired outcomes. Similarly, it is another keyword that is important here and new in this definition is a quantifiable approach. Now, what is a quantifiable approach? That like an approach which is able to measure the effectiveness of our methodology. So here our emphasis would be on quantification, that is whether we have achieved the desired results or outcomes through the process or not. So as compared to quality assurance, here mainly what we are emphasizing on is the managerial aspect. That is, we have to plan better in order to make this process more effective, so that it is in fact a true representation of some engineering activity. Here I will discuss the activities and processes that are involved in quality engineering. Mainly there are three types of activities. These activities include pre-quality assurance activities, in-quality assurance activities, and post-quality assurance activities. As you can see in this figure that we have mainly the entry point. Here we in fact start our quality planning activities, whereas the second type of major activity, that is quality assurance activities. These are in fact the core quality assurance activities that are performed in this process, whereas the third type of major activity in this quality engineering process is quality assessment and improvement. So we will have a discussion on each of these groups of activities in the next slides. Pre-quality quality assurance activities. Uh, you can see that here we have a quality planning as the entry point. So this is in fact the stage where we will do plannings about some activities that are to be performed during the project. So the activities at this stage, they are mainly of two types. The first one is setting specific quality goals by matching the customer's expectations. For example, if the project is from the domain of real-time systems or uh, safety critical systems or some industrial domain, then safety might be one of the attributes that is very important for customers. Similarly, from the project of financial domain, the security of financial transactions, that is very important. So once you have identified the quality goals that are or quality expectations of the users, then we need to identify the measures to see if the selected quality goals have been met or not. Then the second type of activity that we will do at planning is forming an overall quality assurance strategy, which includes two sub-activities. In fact, the first one here is that selecting appropriate quality assurance activities to perform. For example, like shall we perform reviews? Shall we perform inspection, walkthroughs, testing, and like at which stage we will be performing which activity. So the planning about these core quality assurance activities is also done. Then we also choose appropriate quality measurements and models to provide feedbacks, similarly to perform the assessments about quality and revise our strategies for the sake of improvement. So here you can see the arrow going from like quality planning towards quality goals, which is in fact an oval. So it similarly we have arrows going from quality planning towards selected quality assurance activity, and so it means that this is in fact the basic phase where on which all our future activities related to quality assurance they are based. In quality assurance activities, these are activities that are in fact the core quality assurance activities. For example, reviews, auditing, inspection of any artifact, testing. So we will have a detailed discussion on these activities in upcoming lectures of this course. So far, we are only discussing the activities of quality engineering. So I will just keep a focus on those activities. Then the third type of activities in quality engineering are post-quality assurance activities. So these activities are, for example, quality measurement related activities, assessment and improvement. So the primary purpose of these activities is to provide quality assessment and feedback, so that various management decisions can be made. Similarly, the adjustments in the overall process strategies could be made to make the processes more effective. So here the most important thing is feedback from this activity, that this activity provides feedback to the previous activity. For example, it might provide feedback to planning, or it might provide feedback to some other activity. So mainly two types of feedbacks are here, which are which can be characterized as short-term feedback and long-term feedback. So short-term feedback provides information for progress tracking, similarly activity scheduling and identification of areas that need some special and immediate attention, and more and mainly this feedback is from immediate activities, whereas long-term feedback uh, this might be the feedback to quality planning stage, so that necessary adjustments can be made to quality goals and the remaining quality assurance strategies. Here we will discuss the quality improvement paradigm, which is also called QIP, in context of quality engineering approach that we discussed in the previous slides. Quality improvement paradigm was proposed in 1995 by Basili and colleagues. The quality improvement paradigm suggests several activities to achieve quality improvements. These activities include, for example, measurement, analysis, feedback, and organizational support. Moreover, QAP includes three interconnected steps, that is, the understanding, assessing, and packaging, which form a feedback and improvement loop, as briefly described here. So the first step is to understand the baseline, so that improvement opportunities can be uh, identified and clear measurable goals can be set. All future process changes are measured against uh, this set baseline. Then the second step is to introduce process changes through experiments, pilot projects, similarly by assessing their impact and fine-tuning these process changes. Then the last step is to package the baseline data, experimental results, similarly local experiences, and updated processes as the way to infuse the findings of the improvement program into the development organization. So the approach to quality engineering that we discussed here in previous slides can be considered as an adaptation of quality improvement paradigm to assure and measure quality, and to manage quality expectations of the target customers. So here we will discuss some specific similarities between the quality improvement paradigm and the quality engineering approach that we discussed in the previous slides. Uh, the pre-quality assurance activities that we discussed here, they roughly correspond to the understand step in quality improvement paradigm. Similarly, the execution of the quality assurance strategies correspond to the changes introduced in the assessed step in quality improvement paradigm. However, the quality engineering approach we discussed focuses on the execution of normal quality assurance activities and the related measurement activities selected previously in the planning step instead of specific changes. Moreover, analysis and feedback are post-quality assurance activities in the quality engineering approach. They overlap with both the assess and uh, package steps in quality improvement paradigm, with the analysis parts roughly corresponding to the quality improvement assess step and the longer term feedback roughly corresponding to the quality improvement package step. Here we discuss the quality engineering activities in software process. The quality engineering process forms an integral part of the overall software engineering process, where other concerns such as cost and schedule are also considered and managed. Individual quality assurance activities can be carried out and integrated into the software process. When we broaden our scope to quality engineering, it also covers pre-quality assurance, quality planning, as well as the post-quality assurance measurement and analysis activities carried out parallel to and after quality assurance activities to provide feedback and other useful information. All these activities and the quality engineering process can be integrated into the overall software process. Pre-quality assurance quality planning can be an integral part of any project planning. For example, in the waterfall process, this is typically carried out in the phase for market analysis, requirement gathering, and product specification. Such activities also provide us with valuable information about quality expectations by the target customers and users in the specific market segment. um, in the specific market segment, quality goals can be planned and set accordingly. Project planning typically includes decisions on, for example, languages, tools, and technologies to be used for the intended software product. In software processes other than waterfall, such as in incremental, iterative, spiral, and extreme programming processes, pre-quality assurance activities play an even more active role because they are not only carried out at the beginning of the whole project, but also at the beginning of uh, each subpart or iteration, due to the nature that each subpart includes more or less all the elements in the waterfall phases. Therefore, we need to set specific quality goals for each subpart and choose appropriate quality assurance activities, techniques, uh, measurement models for each subpart. The overall quality goal may evolve from these sub-goals in an iterative fashion. For normal project monitoring and management under any process, appropriate measurement activities need to be carried out to collect or extract data from the software process and related artifacts. Analysis need to be performed on this data, and management decisions can be made accordingly then. On the one hand, the measurement activity cannot be carried out without involvement of the software development team, either as part of the normal defect handling and project tracking activities, or as added activity to provide specific input to related analysis and modeling. Therefore, the measurement activities have to be handled online, that is, during the software development process, with some additional activities in information or measurement uh, extraction carried out after the data collection and recordings are completed. The specific analysis, feedback, and follow-up activities in the software quality engineering process fit well into the normal software management activities. Therefore, they can be considered as an integral part of software project management. Of course, the focus of these quality engineering activities is on the quality management as compared to the overall project management. That also includes managing project features, cost, schedule, and so on. The integration of the quality engineering process into the waterfall software development process is illustrated in this figure. The horizontal activities roughly illustrate the timeline corresponding to software development activities. For example, quality planning starts right at the start of the requirement analysis phase, followed by the execution of the selected quality assurance activities, and finally followed by the measurement and analysis activities. All these activities typically last over the whole development process with, in fact, different sub-activities carried out in different phases. This is particularly true for the quality assurance activities with testing in the test phases, various reviews or inspections at the transition from one part to its successor phase, and other quality assurance activities are scattered over the other phases. Here we discuss the effort profile for quality engineering activities. Among the three major types of activities in the quality engineering process, the execution of specific quality assurance activities is central to dealing with defects and assuring quality for the software products. Therefore, they should and normally uh, consume the most resources in terms of human efforts as well as utilization of computing and other resources. However, the effort distribution among the three is not constant over time because of the process characteristics described I just described, and the shifting focus over time. Some key factors that affect and characterize the effort profile are the overall effort distribution over time for different quality engineering activities include, for example, quality planning, quality planning actually drives and should precede the other two groups of activities. Therefore, at the beginning part of product development, quality planning should be the dominant part of quality engineering activities. Thereafter, occasional adjustments to the quality goals and selected quality strategies might be applied, but only a small share of effort is needed in this regard. Similarly, measurement and quality assessment activities start after selected quality assurance activities are well underway. Typically, at the early part of the development process, small amounts of such activities are carried out due to are carried out to monitor the quality progress, but they're not expected to be used to make major management decisions such as product release. These activities peak off right before or at the product release, and then lower gradually after that. In the overall shape and pattern, the effort profile for these quality activities follows that for the collective quality assurance
activities, but with a time delay and a heavier load at the tail end. The general profile is graphically illustrated in this figure. The overall quality engineering effort over time is divided into three parts. The bottom part represents the share of total effort by quality planning activities. The middle part represents the share of the total effort for the execution of selected quality assurance activities. The upper part represents the share of total effort for the measurement and quality assessment activities. It is important to mention that the figure presented here is for illustration purposes only. The exact profile based on real data would not be as smooth and would naturally show large amount of variability with many small peaks and valleys. But the general shape and pattern should preserve, of course. Waterfall process would see more dominance of quality planning in the beginning and the dominance of testing near product release and measurement and quality assessment activities they peak right before product release. Other development processes such as incremental, iterative, spiral, and extreme programming processes would be associated with curves that vary less between the peaks and valleys. Quality assurance is spread out more evenly in these processes than in the waterfall process, although it is still expected to peak a little bit before product release. Similarly, measurement and analysis activities are also spread out more evenly to monitor and assess each part or increment with the cumulative modeling results used in product release decisions. There are also more adjustments and small scale planning activities involved in quality planning, which also makes the corresponding profile less variable. So that's all for our discussion on the concepts related to quality engineering. So, in conclusion, we can say that to manage the quality assurance activities and to provide realistic opportunities of quantifiable improvement, we need to go beyond quality assurance to perform the quality planning before specific quality assurance activities are carried out in the pre-quality assurance activities in software quality engineering. And we also need to set the overall quality goals by managing customers' quality expectations under the project cost and budgetary constraints. Similarly, we need to perform quality quantification and improvement through measurement, analysis, feedback, and other follow-up activities. These activities need to be carried out after the start of specific quality assurance activities in the post quality assurance activities or during the post quality assurance activities in software quality engineering. The integration of these activities with the quality assurance activities forms our software quality engineering process that we discussed in this lecture, and we saw that in the first figure, which can also be integrated into the overall software development and maintenance process. So that's all for this lecture, and the material in this lecture is based on our course book titled Software Quality Engineering, Testing, Quality Assurance, and Quantifiable Improvement by Jeff. For more details, you can consult the book. Thank you.